Okay, so hello, good morning. This is the continuation of the class which we had done earlier. Yes, which was a survival distribution class. Therein we had just dealt with the basic notations of actuarial notations, which was TP, which were TPH, TQH, and T deferred UQH. Now, just to give a quick recap of what we had done in the previous class, TPH essentially meant what is the probability that a H-year-old person would survive for at least T more years, and TQH essentially meant what is the probability that a H-year-old would die within the next T years. There was a third notation as well, which was T deferred UQH, which essentially meant that this is the probability that a H-year-old person will survive for next T years, and then he will die within the next U years. Now, there is something known as consistency principle, which you will have to know before you can derive the formula for T deferred UQH. So, consistency principle essentially says that, let's say if I want to calculate the probability of 5p10, which means that a 10-year-old person will survive for 5 more years. So, I can say that this person will survive for 2 years first. Next, he will survive for 3 more years. So, I can write this as 3p12. So, this is what consistency principle says. Okay, this is a very popular principle which you will have to apply very extensively in your actuarial journey, which essentially means that a person will have to survive for 2 years and then he will survive for the next 3 years. And this 2-year period is assumed to be independent of the next 3-year period. Again, even if it was not, although obviously it would not be independent of it, but this relationship or this dependency would be incorporated implicitly within this. So we don't have to worry about that. Okay, so following that, we can write T deferred UQH as I said, that it essentially means that you will have to survive for T years and then you will have to die within the next U years. So I can write this as T PH multiplied by U Q H plus T. Because after the T years, my age would be H plus T. Now I have to die within the next U years. So that is how we will document, or that is how we will calculate the probability for this. Okay. Now, in an ideal world, you won't be provided with the probabilities straight away. You won't be given with the probabilities and you will have and what with the same. In an ideal world, in a real life, you will be provided with the data, and using that data, you will have to calculate the probabilities, and using those probabilities, you will have to do the pricing, modeling, and all that. Now, the data which is provided to you would be provided in the form of a life table, and this here is a sample life table which will be provided to you. So essentially, what will be provided to you is that they will not give you the exact data which they have recorded. They will give you a representative data. They will give you a data which is a representation of their original data. Okay, because what it essentially means, why I am saying this is because if you look at the first figure, this essentially means this data, this value essentially means that this is the count of population or count of policyholders who are alive, who are aged 20. And again, this is a count of population who are alive at age 21. This is the count of population who are alive at age 22. This is the count of population who is alive at age 23. So basically, 95,871.68 people are alive at age 23. Now it seems very unreasonable to have a non-integer value here, but as I said, this is a representative data. This is not the actual data, so you do not have to worry about this being in decimals. Now, there is a third column here, which essentially means, which is of DH. DH is nothing but the count of people who have died between H and H plus 1. So this data, this is the data of D20, which means the number of people who have died between 21 and 20. So how to arrive at this figure? I have just simply subtracted this value and this value. So basically I have taken the difference of this value and this value to get our answer as 99.0569. I would encourage you to do the calculation for the rest of the values as well and get the answer. So how do we work with this data? How do we use this data to our advantage? So let us say this is a word example for you guys. So how do we derive the answer, or how do we work with it? Now I want to calculate 5p20, which is the usual case, which I just want to know what is the probability that a 20-year-old person will survive for 5 more years. Okay, so this is a very simple example, right? And how do we calculate this? We can calculate this very, very easily using the very basic principles of probability which we have learned ever since we were kids, which was number of favorable outcomes divided by the total number of outcomes. Herein, I am currently a part of these policyholders. Okay, so I'm a part of these policyholders, but I want to be a part of these policyholders because 5p20 means a 20-year-old person will survive for 5 more years, right? So I'm currently a 20-year-old, but I want to survive for 5 more years. So basically, I want to be a part of this population. So how do we calculate this? We can, as I said, I will just have to write number of favorable outcome in the numerator, which is 95650.15, and in the denominator I will have to write the number of total outcome, which is 96178.01, and after solving this I will get my answer as 0.994512. So there is a 99.45% chance that I will survive for 5 more years, which seems reasonable. Okay, so this is how we use the probability values. Next up, next we'll have to calculate the probability of death. Now let us say I am a 24-year-old person. If I'm a 24-year-old person, I want to know what is the probability that I will die within the next year. Again, I will use the same concept as before. I will use number of favorable outcome by total number of outcomes, right? So I will simply use that to get my answer. Okay, and how to do that? As I said, I am a 24-year-old person. So basically, I am a part of this population, and I want to die within the next year, right? So DH essentially meant, as I had defined earlier, DH essentially meant number of people who have died between H and H plus 1. So basically, this means the number of people who have died between 20 and 21. So recursive, if we just go on and on and on, I will ultimately get to this value, which essentially means the number of people who have died between 25 and 24, which is what I want. So I will have to be a part of this population. I will have to be a part of this. I want to be a part of this population, right? So number of favorable outcomes, which is equal to 112.7102 divided by 95762.86, and solving this I will get my answer. Okay. Next up, for the next part we have 4 deferred 1 Q20. So 4 deferred 1 Q20, as we have already discussed, essentially means that a person aged 20 will survive for 4 years and then he will die within the next 1 year. So I will survive for 4 years and then I will die within the next 1 year. So I can write this as 4p20, which is the probability that I will survive for the next 4 years, and then I will have to die within the next year. But once I have survived for 4 years, I will no longer be a healthy young boy or 20-year-old. I will be a person who is aged 24. Okay, we have already calculated the value of 4p20, right? So we can just straight away put that 4p. We have not calculated 4p20. We have calculated 5p20. No issues. So 4p20 is this 95762.86 divided by L20, which is 96178.01 multiplied by Q24. So again, I can just simply use this value to get my answer. Okay. So this is the answer that I'm getting. So after solving this, I can just simply cut this and this part, and I will get to this 112.7102 divided by 96178.01. After solving this, I will get my answer. Okay. So this is how we deal with the probabilities. This is how we use the life table functions to calculate the probabilities. Now I would encourage you to try more probabilities using this life table and let me know if you face any problem. You can contact me at 8100598543. Again I will repeat the number, which is 8100598543. Call and ask for Devansh, which is me. You can get to me and I will help you. Okay, so happy learning. This is it for my side. Thank you.